Hello everyone, this is Ritanish, roll number 17EC01002. I'm a third year undergraduate of Electronics and Communication Engineering at IIT Bhubaneswar. This is the second week of video series of Digital Signal Processing Lab. In this video, we're going to see the filters used in previous lab get applied to a live data from PPG sensor and a set of ECG data. The ECG data contains 1000 samples and the PPG sensor data has 500 samples taken at regular intervals. Now let's see the moving average filter and difference filter get applied to each of these data. Now let's see the Arduino code for PPG data of this. Here we're going to initialize the arrays, and this is the naming of the plots of serial plot, naming the plots which we're going to plot later. And here this is where we read the data. For reading the data from Arduino into the Arduino, we're going to use analog read function because we're going to read analog values, the digits, not just on or off. For on or off, we use digital read. We're going to put the data pin of PPG sensor in A0, so we're going to take a analog read of A0, and here we're going to give a delay of 10 milliseconds, thereby making the sampling frequency of this signal 100 Hz. We're going to take a sample size of 500, and then we're going to wait some time, and then we're going to take another 500 samples in 5 seconds. Now moving on, we're going to pass that data through a moving average filter of order 8. It is important that the moving average filter be placed in the void loop because the data keeps changing every 5 seconds or so. And here we're going to print plot the data, the values which we get. We're going to plot the moving average filter, the first order difference filter, and the 3-point difference filter. In blue is the original data, and in red is the moving average filter data of order 8. We do not see much smoothing because the signal is already smooth. Yes, here we see a little bit of noise, and here it's not there. Thereby the smoothing can be observed. In red is the first order difference filter, and in yellow is the 3-point difference filter. The filters can be referred to in the previous video. Now let's take a look at the Arduino code for ECG data. The ECG data contains 1000 samples, 1000 samples as mentioned here, and here we're gonna just name the plots. Here we're gonna use two moving average filters, one of order 2 and one of order 8. We're gonna use the moving average filter of order 2 for further operations. The reason will be shown when the graphs are shown. Here we're gonna write the code for, here is the code for the moving average filter of order 2, and here is the code for moving average filter of order 8. Again I'm saying, for explanation of these codes, for explanation of codes, moving average filter and difference filters and baseline removal, just refer to the previous video. And here is the code for plotting the plots. We're gonna plot moving average filter of order 2, moving average filter of order 8, and difference filter of first order, and 3-point difference filter. For these we use moving average filter of order 2. In blue is the original data, and in red is the moving average filter of order 2, in green is the moving average filter of order 8. Here we see that if we use moving average filter of order 8, since there is a very narrow spike here, the signal got smoothed out pretty there was a bit more smoothing occurred than it was required. So we use moving average filter of order 2. In gold is the first order difference filter, and in violet, purple, something is the 3-point difference filter. In gold, the gold plot is right behind this purple. We can't see it because it kind of overlapped, but it's there. Next, baseline removal. Again, for Knowing what baseline is and why we should remove baseline, just refer to the previous video. It is imperative that we remove the baseline. Arduino code for removing baseline in PPG data. Here we're gonna set up the arrays and name the plots, read the data in this line of code. We know that in baseline we take about zero point 0.8, we take a smoothing filter of order about 0.8 times the length of the signal, and this is the, and then since the PPG signal length is 500, we take a smoothing filter of order 400, and this is the code for passing the signal through the said aforementioned smoothing filter, and this is the code for printing it. In blue is the original data, in red is the baseline, and in green is the baseline removed signal. We're gonna inspect the Arduino code for ECG data for removing baseline signal. And since the Arduino, the data length, the sample length here in ECG is 1000, we're gonna take our smoothing filter of order 800. It is important to note that whenever we are using ECG data, we set up the smoothing filter and the difference filters code in setup loop, because it saves RAM in Arduino, because setup loop is executed only once and the ECG's data here is not changing. And in loop we only just keep on printing the signal baseline and signal minus baseline. The yellow is the original signal, and in green is the baseline signal. In red is the, well, in red is smoothened and baseline removed signal. That's all. Thank you very much.